Today we're going to be preparing for our Unit 6 test. You should have a study guide if you're in class. If you're doing this at home on your own, there's a link to the study guide in the iCan. Question number 1 asks you to rewrite the expressions using the rules of exponents. Final expressions are to include only positive exponents. When you're in doubt, expand it out. You can do this, guys. We start off with x squared times x to the 6th. If you remember the rules for exponents, when you have the same base and you're multiplying, you add 6 plus 2. So this should be x to the 8th. Same base, multiplying, add the exponents. For b, we have something in parentheses. We have 5x squared y cubed. So 5 is being raised to the 4th power. Look outside of the parentheses. X squared is being raised to the 4th power, and y cubed is being raised to the 4th power. Bring that 4 into the 5, so that's 5 to the 4th, and then x squared to the 4th. Remember, when you're in doubt, expand it out, so that would be x squared, that's x times x, 4 times. 1, 2, 3, 4. X squared is x times x. We have those pair of x's multiplied 1, 2, 3, 4 times. Count them up. That's x to the 8th. That's the power to a power rule. Okay, so y cubed 4 times is going to be 3 times 4, y to the 12th. Go ahead and expand out 5 times 5 times 5 times 5. 5 to the 4th power, or you can put this in your calculator, is 625. X to the 8th, y to the 12th. The rule is when you raise a coefficient to a power, you multiply the exponents. On C, we're dividing. This fraction bar means division. So let's take the 10 divided by 2, that's going to give us 5. When you're dividing and you have the same base, we have the base of x on the top and on the bottom, x to the 3rd and x to the 8th. The rule is to subtract exponents. So 3 minus 8 would be negative 5. So that would be x to the negative 5. Let me write that out. We did this part right here. 10 divided by 2 is 5. And then x, when we're dividing, we subtract the exponents. 3 minus 8. Let me bring this down. 3 minus 8 is negative 5. And then we have a 2 with the y as the base on the top and a y on the bottom. Let's go ahead and write that 1. This is y to the 1st power. So you can see that we're subtracting the exponents. 2 minus 1 gives us 1. So this is going to be 5, x to the negative 5, y to the 1st power. I'm not going to write that 1. Alright, we can't have a negative exponent, so I need to write a fraction bar. Bring all of this down to the bottom. When we cross that fraction bar, it makes that exponent positive. Okay, cross that out, bring it down to the bottom. So this is 5. Let me go ahead and uncover this. Y on the top and x to the 5th on the bottom. Remember what the division rule is. When you're dividing and you have coefficients with like bases, you subtract the exponents. All right, make sure that you write this down on your study guide. Let's go to question number 2. In a study of crickets in a lab, a scientist notices that the amount of crickets is 4 times as many as the week before. 4 times as many. This looks like it's going to be an exponential equation. Okay, so what happens is we start with 20, that's our initial amount. We multiply by 4 and we get 80. And do we multiply by 4 again to get 320? 8 times 4 is 32. Put that 0 on the end. That looks correct. All right, so how would we write that rule? Think about what we're doing. Here's our equation for exponential growth. Y equal A times B to the X. A is the initial amount. On our table, the initial amount that we have here is 20, so that 20 would go where the A goes. And then B is our growth factor. What are we multiplying by each week? Let's put that in an equation. C, we're going to use C for crickets, so we're going to replace Y with C. Okay, and X is going to be replaced with W for weeks. X is always time. So we start with the initial amount 20. That's what our A is. Our growth factor is 4, so we're going to multiply by 4, raised to the W. Remember, we're exchanging Y with C. Crickets is our outcome. Our Y is always outcome. And our time is W. Time is always going to be our X value. Write this down on your study guide. A is the initial amount when X is 0. B is the growth factor, what you're multiplying by, and X is time. Question number 3, we have 3 functions, g of x, h of x, and f of x. They're represented below. Your job is to list the functions from greatest to least based on the growth factors. So let's look at the table. We have these represented 3 different ways. The first one is in a table, the second one is in a graph, and the third one is in a function. All right, so let's look at this first one. We have 0 right here, so our initial amount is 2. Let me see if I can convert this to an equation or a function. So f of x is equal to the initial amount. So if we know what, when x is 0, what y is, that's our initial amount. Okay, so how do we get from 2 to 6? What do we multiply by? 2 times 3 is 6, and then 6 times 3 is 18, and then 18 times 3 is 54. So our growth factor is 3, and we're raising that to the x. All right, so we know what our growth factor is for this one. You can look at the table. You can go from 0 to 1 or from 1 to 2. Take that second number, divide it by the first, and you have what you're multiplying by. So now let's look at the graph for g of x. Okay, we still have 2 numbers, an x and a y, an x and a y. We know what x is when x is 0, we know what y is. That's 0, 1. So we can put these numbers in a table, or we can say we're going from 0 to 1, so we're moving in 1 increment of time. So how do you get from 1 to 1/3? This time you would have to take 1 and divide by 3 to get 1/3. And you can see that we're not growing, we're decaying, we're dropping down. So our growth factor, or the better way to say this is our decay factor, is 1/3. Okay, our initial amount is 1. That's where it crosses. When x is 0, that's what y is. Okay, so we can see what that is. Where it crosses the y-axis, it crosses at 1. And here's our function. So our growth factor for g of x is 1/3. Now when we have the equation, we can just find our growth factor here. So we have a growth factor of 2, an initial amount of 400. So we want to put these from greatest to least based on growth factors. Okay, the largest growth factor is 3. So this is the first one, f of x. Okay, so 3 is greater than 2, so h of x comes next. And then 1/3 is the smallest, so g of x should be last. Okay, let's see if we got that right. F of x, h of x, and g of x. All right, let's move on to question number 4. We want to match the graphs to each description. Is our graph increasing exponentially, increasing linearly, decreasing exponentially, or decreasing linearly? We know that increase is rising and decreasing is falling. So graph A is rising, and this is a linear function. So let's find the increase linearly. That's going to match with A. Now this is a linear function. It makes a line, and it's decreasing, it's falling. So we need to find decreasing linear for B. Now the curve is an exponential function. This one's rising, and this one's falling. So this is increasing and then decreasing. So C, increasing exponentially, goes right here, and then decreasing exponentially goes right here. You will have a matching like this on the test, so ask questions before you take the test if you don't understand this. Go back and watch the video recording, take notes, whatever you need to do. Understand the vocabulary. Increasing exponentially and decreasing exponentially, those are going to be curves. Increase goes up, decrease goes down. Increasing linearly, that's a line, so that's going to slant up. And then decreasing linearly is going to slant down. Question number 5. The amount of aspirin in a person's body is given by the function a times a of t equals 300 times 2/3 to the t, where t is the number of hours since an injection. We want to know how much aspirin will be in a person's body after 3 hours. Okay, look at this function. You can use Desmos and put this in your calculator, or you can take this expression, 300 times 2/3 raised to the 3rd power, because time is always going to be our exponent. 300 times 2/3 raised to the 3rd power is 88.89 milligrams. Get used to using either a handheld calculator that we have in the classroom or Desmos. Desmos will be available for you on this test. What does 300 tell us about this situation? If you look at this equation, 300 is our initial amount. Now let's put that in a complete sentence. This is the amount of aspirin injected into a person. It is the initial amount or the starting amount. So make sure that you're writing your answers in complete sentences. On some of the cool downs, I've given you feedback. Just an answer is not going to give you complete credit, and you may not pass the test unless you practice writing your answer in a complete sentence as it relates to the word problem above. What does the 2/3 tell us about that situation? Well, the 2/3 is going to be our growth factor. Now this 2/3 is less than 1. This is going to be the amount remaining after each hour since the injection. So each hour, the aspirin remaining is multiplied by 2/3. Now, if you want to say it decreases by 1/3 each hour, that's another way to say that. You're asked to graph the function for the values of t between 0 and 4. So I put this in Desmos, or I put it in a table. And at 0, we start with 300. At 1, we're at 200. Okay, 200 times 2/3 brings us down, don't have that exact amount, 200 over 1 times 2/3 is going to be 400 over 3. 400 divided by 3 is somewhere between 100 and 150. Again, relying heavily on the calculator. Get that amount, multiply by 2/3 to get how much is remaining in that next hour, and then in the 4th hour you keep multiplying. Alright, so graph, either use a table, but you need to use your calculator to get those exact amounts. Alright, what domain and range below would be the most appropriate for the situation? Now, the first time I did this, I was rushing and I didn't get the right answer because I wasn't looking closely, and I'll show you what I mean. Alright, the domain are your x values. Okay, we are going to start at 300. We can't go below 300 because that's the initial dose. Okay, so we're not going to go into the negatives. That doesn't make sense. We're going to stay in quadrant 1. Now, as we move each hour, we're going to go up to, I guess we could go up, never stop, right? So our domain is anything over 0, any hour over 0. We'll technically never get to 0. Realistically, we will, but we're approaching 0 as that cycles out of our body. Now, the range is going to be the outcome. The range starts at 0 because we're going down. Okay, approaching 0 as we move out each hour. That dose is cycling out of our blood. So 0 to 300. Okay, now I chose A, but the answer is C. Simply because this says greater than, and this says greater than or equal to. Now we can equal to 0. So just be careful that you don't make the mistake that I made. And rush. Choose C. Okay, the domain is the time. Okay, time starts at 0 and time keeps moving forward. So it can be anything greater than 0. The range can't cross the x-axis, so it never reaches 0. The amount stays between 0 and the starting point. Question number 6. The value of a computer purchased in 2019 is modeled by the function c of x equals 2700 times 0.65 raised to the x power, where x is the number of years since the computer was purchased. X is always going to be time. What is the initial value, and explain what it means in this situation? Okay, so if you just put the initial value as 2700, you're not going to get full credit for this question. What does it mean in context to this problem? It's the initial amount, it's the cost of the computer in 2019. We're using C for cost. Identify the growth or decay factor and tell us what it means in this situation. So the growth factor is 65 hundredths. Now this is less than 1, so we actually call that the decay factor because it's less than 1, which means the value of the computer is decreasing by 35% each year. This is the amount that we multiply. This is the amount that remains. The decay factor is 65%. It's decreasing by 35% each year. Question number 7. Mr. Golden wants to raise money to put in a swimming pool for our swim team. He isn't sure about which is the best way to increase funds faster over the next 8 years. Since he wants the pool to be built in 2030, he doesn't have a lot of money to invest, but these are his two options. He can invest $10,000 in an account that earns 9.5% interest each year, or he can invest that same $10,000 and add $1,000 each year. What's the best option based on your calculations? So what I would do is write an equation for each of these. This first one, we're earning 9.5% interest on the amount that we put in. So we would add 1 or 100 to 1.9. Start with our initial amount, 10,000. We're going to multiply that by 100% plus 9.5%, that's 109.5%. $109.5. Now to change that to a decimal, move the decimal 2 places to the left. So that's 1.095. That's what we'd multiply by each year. Okay, we're going to raise that to the x. Okay, so that's what our equation looks like. You can use function notation as well. Instead of y, you can put f of x. All right, go ahead and graph that. Put that in your calculator. Y, or f of x, equals 10,000 times 1.095 to the x. This second equation is linear because we're adding. So we start with the initial amount of 10,000 plus 1,000 times x. Y equal, here's our mx, so the slope is 1,000, and here's our intercept. Okay, put those in, and maybe if you graph those, you can tell which one is going to be the better option. So we're only going out 8 years. Okay, let's see if we got those equations right. Okay, I put y, they put f of x. Put those in your calculator. Looks like we got those right. In the calculator, when we get to 8 years, you can look at your graph. You can pull it over to 8 on the x-axis, or you can simply take that expression in each of these and replace the x with an 8, and you'll see that option 1 is the best option, where we're earning 9.5% interest. Now go through the question that you get like this on your test slowly and carefully. Make sure you're doing the calculations and not rushing through. Question number 8. Marshall bought 4 goldfish at the beginning of the month. 1 month later, the number of goldfish in his tank had tripled, so our growth factor is 3. His goldfish population continued to grow in the same manner. We want to create a function g, g standing for goldfish, to model the growth of Marshall's goldfish population, where g of n is the number of goldfish at the beginning of each month, and n is the number of months that have passed since she bought the 4 goldfish. So g of n equal, the initial amount is 4. Our growth factor is 3, so we're multiplying by 3, and we're raising that to the nth power. You can put that in Desmos. You can see how it works. And you can go over on the x-axis to 10 to find what y is. Okay, but you don't need to find that amount. You need to explain what that amount means in context of this problem. What that means is this is our x. This means in 10 months, this is the amount of goldfish that we'll have. If you're asked to find that amount, look at your equation, replace that exponent with 10, and you'll get 236,196. G of 10 means the number of goldfish after 10 months. Now I want you to create an equation to determine how many months it will take to reach 120 goldfish. Now I took some snippets of Desmos, and I couldn't get right to 120 because you can see I slid up here on my line. I put in both equations. I put in G of n equals 4 times 3 to the n, and this is that line that kind of curves up. And then I put x equals 120, and I tried to see where they intersected, but I couldn't get exactly 120. But I slid up here and look at what the x is. A little after 3 months, okay, we get to 120. Okay, somewhere between 3 and 4 months, a little after 3 months, we reach 120 goldfish. So practice putting that into Desmos. Let me know if you have any questions about how to solve this problem with your calculator before the test tomorrow. All right, we want to create an equation to determine how many months it will take to reach 120 goldfish. So we have that function. We got that previously. G of n equals 4, our initial amount, times 3, the growth factor, to the n. So I would put 120. That's how many goldfish we're looking for. That's the output. Equals 4 times 3 to the n. I could divide both sides by 4, and I'm looking for a number that we multiply 3 to itself by in order to get 30. Because 120 divided by 4 gives us 30. That's the way to do it algebraically. But I'm going to create a table because it's easier for me that way. So when we start out, we start with 4 goldfish. After 1 month, we're going to triple that. We have 12. 2 months, triple that again. We have 36. 3 months, triple 36. You have 108. And in 4 months, triple that again. You have 432. And in 5 months, you're going to triple that, and you get 972. If I did my math right, you might want to check these numbers. Okay, now I took some snippets from Desmos when I graphed this, because I wanted to see where I was when I began. 0, 4, that's right here, and then 1, 12. You want to plot those points on your graph. 2, 36, 3, 108, 4, 432. It should be 324. So here's a mistake right here. I'm going to correct that. 324. And then 5 is 972. Okay, I'm just plotting these points. All right, it says, part E says Marshall's sister Maddie bought some neon tetras at the same time. The table below shows the number of neon tetras T after n months. So this is the second equation. And let's see what happens with the tetras. We're going from 6 to 12, so it looks like we're multiplying by 2. So we're multiplying by 2 to get to 12. But if I multiply by 2, I don't get to 18. So that multiplying is not working. Let's see if we're adding. Okay, to get from the tetras from 6 to 12, I would add 6. Now let's see if that pattern works here. If I add 6 to 12, do I get 18? Yes. If I add 6 to 18, do I get 24? Yes. And if you add 6 to 24, I don't get 32. That should be 30. I wonder if that's a mistake. Some of these slides have mistakes here. All right, let's see what that function is. This looks like we're adding. Yes, we start out with initial amount of 6 plus 6 times n. Okay, let's try 4. 6 times 4 is 24. Plus 6 is 30. So this is a mistake in your book. Cross that out. That should be 30. All right, and this is how we write the equation. In a linear function like this, we start with the initial amount and then we add something. So we're adding 6. We're going to multiply that times n. In an exponential function, we start out with amount and then we multiply. In this case, we were multiplying by 3 each time. All right, part F, use graphs to estimate the number of months that will have passed when the population of goldfish and tetras will be the same. So I have these two functions. The exponential function, g of n equals 4 times 3 to the n, and then for the tetras, t of n equals 6 plus 6 times n. Now I graphed these and I zoomed in. Let me show you. I zoomed in and I saw where both of these graphs intersected. I clicked on that point and that's going to be, they intersect. They're both going to have 12 fish after 1 month. Now let's see how we get that from our table. Goldfish and tetra will be the same at 1 month. So I did that by graphing to see where they intersect. Okay, but let's do this with a table. Okay, for goldfish, we start with 4, and then 3 to the first power is 3. 3 times 4 is 12. 3 squared is 9. 9 times 4 is 36. And then finally, 3 cubed is 27. 3 times 3 is 9. Times 3 again is 27. Times 4 is 108. Now let's look at the function for tetras. We're going to start with 6, and then we're going to add 6 each month. So 6 plus 6 gives us 12, and then we can also see the answer from the table. Then we're going to add another 6 to get 18, or 6 times 2 is 12 plus 6 is 18. You can substitute the months in. And then finally, 3 times 6 is 18 plus 24. I'm sorry, plus 6 is 24. All right, the tetra's growth is linear. I've zoomed in so you can't see it really well. That black line is linear. And then the black line is curving, but it's curving slowly. And the blue line is straight, it's linear. The goldfish growth is exponential. So practice putting these into Desmos and then adjusting, zooming in or zooming out, adjusting with the little wrench in the upper right hand corner to see if you can see the graph and you understand what's happening. All right, that's all as far as the review. Make sure that you go over this and you prepare for your test tomorrow. Make sure that you're going through the summary and glossary and understanding vocabulary and how to respond and answer. All right, good luck, guys. You got this.